As we continue our study of algebra and build concepts, it's time to introduce the idea of an exponent. Start with what is an exponent? So this is a good definition of an exponent. It tells us how many times a number or variable is used as a factor. Now, as we move forward in math, you're going to find that this definition might break down a little bit as we get to more and more complex ideas with exponents, but this is the best place to start off. It tells us how many times we're going to use something as a factor. Now, to understand that definition, you still need to remember what a factor is. A factor is something that is multiplied. So when we're talking about using it as a factor, we're talking about how many times you'll see that number in a multiplication problem, not necessarily how many multiplication symbols you'll see. And I had a student several years ago take me to task on defining an exponent as how many times something is multiplied by itself, because that student was looking at the number of time signs and not the number of variables or expressions that were being multiplied. So we want to be really, really clear about that. Exponents are written as something called superscripts, okay? And because I kind of like words, we'll break that down. Super means above. Okay, if your teacher tells you you're doing super in class, usually means that you're doing above average, you're doing above where most students are. And script refers to writing. And in math, we're also going to see what are called subscripts, which would be like below or under writing. A superscript is writing that is smaller and it's slightly above the line of the number or variable. So you can see an example of an exponent right here. So we've got the 3, that's called our base, okay? And the 4 here is called the exponent. And the 4 tells us how many times we're going to see that 3 multiplied in. So 3 to the 4th power means this. It means 3 times 3 times 3 times 3. So the 3 is used as a factor 1, 2, 3, 4 times. Now, this is where the student kind of took me to task is if you say, and you might have heard teachers do this, an exponent tells you how many times something is multiplied by itself. Some students will look at the time signs and they'll look there and they'll say, well, that's only multiplied 3 times. So we want to be, again, really clear. It tells us how many times we're going to see the 3. 3 to the 4th power means that you'll see 3 as a factor 4 times. Now, over to the right there, I have how do we say this out loud? Because how we express things verbally is a huge part of how we communicate math to others. So some of the ways you could say this out loud, we'll say 3 to the 4th power. Okay, and you might hear exponents referred to as powers. That's another thing you might hear. So 3 to the 4th power. You might hear 3 with an exponent of 4. That would be an acceptable way to say that. I had a friend in grad school who was from another country, and she would say something like 3 to the power 4. And that power there should not have an S on. 3 to the 4th power, just 3 to the 4th power. 3 with an exponent of 4, or 3 to the power 4, or 3 to the power of 4. Okay, are different ways that you might say that. So when you're speaking in class, when you're speaking to your teacher, you don't want to say 3, 4, or 3, 4 up, or just making up your own way of saying it. So this is 3 to the 4th power, or one of those options there. Now, this also applies to variables, so you can raise variables to powers as well. So this would be x to the 5th power, and that means that x is used as a factor 5 times. So if you count up how many times you see the x there, 1, 2, 3, 4, 5. So essentially, this is on the last slide of this presentation, the exponent is a shorthand way of writing repeated multiplication. Now, they do get more interesting than that. So we have when exponents are applied after parentheses. So this is where you might have an exponent applying to an entire expression. They apply to the expression as a group, not to the individual members inside it. So x plus 3 raised to the third power. You want to look really closely at what is the exponent being applied to. It's being applied to the parenthesis, which means it's the parentheses that are being raised to the third power. So when we go to expand this, we would say x plus 3 times x plus 3 times x plus 3. We do not take the exponent and say it goes with the x and the 3, so it's x to the third power plus 3 to the third power. And we'll get more into that in our next lesson when we talk about order of operations. So remember that when the exponents are applied after parentheses, it applies to the expression as a group. I cannot emphasize this enough. This particular concept causes a lot of problems later on in math. So the better you lock this in right now, the easier it'll go later on in your algebra journey. Now, a key idea here is exponents only apply to the number variable expression immediately to their left. So here, if you look here, we've got two examples, and if you were to read them out loud, they might be read the same way. So you might say 3x squared or 3x squared. Now, sometimes in this second one, you'll hear somebody say 3x all squared. And so they'll literally put the word all in there as a way of indicating that there are parentheses. So 3x all squared, meaning group the 3x together, the 3 and the x together. That can be difficult to say out loud, and you can see where there's obviously some space for some confusion, but these are not the same thing. In this first expression, the squaring only goes with the x. And so if we were to expand that out, it would be 3 times x, because only the x is being squared. In the second expression, because the 2 is outside the parenthesis, and we know that parentheses will get multiplied in as a group, this would actually be 3x times 3x. So in one of them, you're squaring the 3. The other one, you are only squaring the x. Now, what a lot of people will do is they will use what's called the commutative property of multiplication. I'll do a little side lesson here. The commutative property of multiplication says essentially this, that we'll do 2 times 3 is the same as 3 times 2. In other words, you can switch the order. And what they'll do is they will switch that order right there. And so they'll say 3 times x, and that just kind of groups the things that are similar together, so they're not spread out kind of awkwardly, but both answers would technically be correct. It's not more correct if you decide to group your constants together. All right, so how can we evaluate expressions with exponents? Well, the same way we evaluate other expressions, we simply plug in the value. Now, I am going to encourage you to do it this way. I'm going to encourage you to expand that out first, and I'll show you why in a moment. So that is 3 times x to the fourth, so it is the fourth, the x that's being raised to the fourth power. So now we'll go ahead and plug the 2 in. And what do we have here? We have 6 times 2 is 12, times 2 is 24, times 2 is 48. And you can dump that into a calculator if you're allowed to use one. The reason why I encourage you to do it this way is if you plug it in like this, there is a common mistake where students will try to multiply the 3 and the 2 first, and then they will say 3 times 2 is 6, and 6 to the fourth power is not 48, and they will land in the wrong spot. So we really want to remember that that exponent only goes with what's to the left. Now, if you think you can do it that way and you are good to go, what is that? That is 16, and go that way, that is perfectly okay. Okay, you can get your smiley face for doing it that way. Not going to be an issue. Just make sure you don't fall into the trap of multiplying the 3 and the 2 first. For this last one, we have a plus b raised to the third power. Evaluate that for a is equal to 1 and b is equal to 3. So we have 1 plus 3 raised to the third power. So you can do that a couple of different ways when you're writing it out. Most people would say 1 plus 3 is 4. and then we just make sure that we apply that exponent to all of it, which we did because we added them together. So that is 4 times 4 times 4, or 64. But you can get there in some other ways. You could do 1 plus 3 times 1 plus 3 times 1 plus 3, and that would also get you the 4 times 4 times 4, or 64. Now, I like doing it different ways because I think the more fluent you are at the different ways you can write this, the easier it'll be when we're working with more variables and fewer numbers. If you understand how this process works and the order that it works with the numbers, it translates better. So feel free to play around with these and just rewrite them in as many ways as you can think of that will get you to the right place. Key idea, an exponent is shorthand for repeated multiplication. I mentioned that earlier. It's in the same way that multiplication is short for repeated addition. This idea is critical for understanding why order of operations makes sense. Order of operations is coming up soon in our lesson series, and the more you understand where these operations come from and how they're related to the other operations, it makes the order that we perform them in something that's more concrete to you and not just a rule to memorize. Please like and subscribe. My brother teased me. He said you're going to be a person that says like and subscribe. Yeah, kind of. If this video was helpful, please give me a like, subscribe, leave a comment, and check out the Exponents practice set in the link above or in the description box. Thank you very much.